Welcome to my channel. Your tutor Mariam is here. It's the 14th video of Introductory Physics 1 and the first video that I'm going to talk about the vector, which is the third subject of Introductory Physics 1. In this video, I'm going to talk about two different quantities as a vector and a scalar and what's the difference between them. So it's going to be a basic idea about the vector and properties, and I'm also going to solve the couple of basic examples, like simple ones. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and a like for more. You ready? Let's get started. So there are two different quantities as a scalar and vector. What's the difference between them? So for the scalar quantity, it's specified with the value. It has unit and magnitude, but they don't have a direction. As a vector quantity, we have the value and also they have a direction. So as an example of the scalar one, I can mention mass or volume. And as a vector is like a displacement or velocity. So let me show you what I mean. Let's say I have a ball and I'm going to move it to this point right here, right? So then I'm going to say the displacement here, x, gonna be 5 meters, right? So what I just told you is the value or magnitude, right? So if I tell you I move the ball for 5 meters, you don't know if I move it forward or backward, right? So if I want to make it more clear, I can say I move it forward, right? How can I show that? I can put a direction on it, right? Like the other way, I can say that is like I move the ball in the positive direction and give it as a vector. Like say it's gonna be in the positive direction and give it to like something like this, right? Then I represent this displacement as a vector, not a scalar quantity. To make it more clear, let's go with choosing the origin. Like I have this coordinate as a x and y, right? And now I move the object from origin to this point right here, right? I'm gonna say this is gonna be 0, and then this guy's right here gonna be 5, right? Now it's clear. I move it in the positive x direction and I can represent it as a vector. So now I can tell this guy gonna be like this. This is the y-axis, x-axis, and now I can show it as a vector, right? So it's going to be my vector from origin to the point I have a ball, and I can call it as A, right? So this is how I can represent the vector and the difference between the scalar quantity and the vector quantity. Vector quantity must have a direction. Now let's look at some properties of the vector. So the first property is like vectors can be equal to each other. That means they must have the same magnitude and direction. For example, here you can see A and B is equal to each other because they have the same magnitude and direction. However, the one you see right here, they are not equal. They have the same magnitude, but if you look at the direction right here and here, they don't have the same direction. So I can tell they are equal because they don't have the same direction. So direction and magnitude both should be the same, okay? The second property is they can be added or subtracted. It's called the commutative law. Here you can see how vector A and B add together. So the result is like it's started from the tail of the vector A, and it's going to be ended from the from the head of B. This is how you can add the vector together. But let me show you more example. So let's see how I can add vector A and B. So for adding vector A and B, it's gonna start from tail of A, right? And it's gonna be ended to the head of B, right? So this gonna be A plus B. Now let's add B and C. Let's see how it looks. So again, it's gonna start from B, and then it's gonna be ended to C, right? So this is gonna be B plus C. How about A plus B plus C? So again, it's gonna start from point A and then ended with point C. So this guy is gonna be A plus B plus C, right? So I'm hoping with this example you understand how to add the vector together. Now let's go back to the properties. The other properties is like vector can be negative. For example, I have vector A, right, and minus A means that it has the same magnitude but different direction. As you can see here, the direction of A is upward, however the direction of minus A is downward, right? And also they can be subtracted. So I can subtract vector A to B from B, right? But the meaning of this subtraction is like I'm adding two vectors together, but the second one, or I would say the one is negative, is like is the negative vector. So technically speaking, I'm adding two vectors, but one of them has a negative direction. This is another way you can think about it. And then the last property is going to be the vector can be multiplied by a scalar. So it can be a smaller or bigger by multiple with a scalar. So what that means? For example, I have vector A, right? And I multiply by minus 2. So if I'm going to do that, it's going to be this vector going to be times 2, and also the direction going to be changed, right? And if I multiply by positive 2, then the direction going to be the same by magnitude going to be twice more than A. Okay, let me show you an example. So for example, vector A has a magnitude of 4, right? And then if I go with 2A, then it's gonna be 8, right? The magnitude gonna be 8 because it's gonna be 2 times 4 is gonna be 8, right? If I multiply by minus 2A, then it's gonna be minus 8, right? So the direction gonna be changed. The difference between 2A and minus 2A, that's this tip right here. So this direction is changed because one of them is positive, the other is negative, and also the magnitude is like twice more than A. I'm hoping this video helped you to understand the properties of the vector and the difference between the vector and a scale. In the next video, I'm gonna solve a couple of examples about this. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button, and see you in the next video.